Hello, my name is Rachel Dziuba and I am from Our Lady of the Lake University. Today we will be looking at how we can model predator-prey interactions between mountain lion and deer populations in Bulverde, Texas. We will be focusing on understanding the preliminary theory of typical and actual behaviors of these two populations, as well as the known predator-prey models that we can use to understand how they interact. So a predator-prey interaction involves two species in which one benefits while the other is negatively affected by being eaten. Predators are favored to evolve traits that will help them catch and eat the prey, while prey are favored by natural selection to evolve traits that will help them to avoid being eaten. One way that prey can reduce the probability of being eaten is the dilution effect, which happens when a prey has a reduced probability of being eaten when they're in a group. So a group of 4 deer reduces the probability of this one deer being eaten, rather than if that one deer is alone, they have a higher probability of being eaten by a mountain lion. These interactions may also be affected by the different populations' spatial heterogeneity by differentiating between the prey population and the amount of prey available in relation to the distributions of the predator populations. So here is a map of the area that we're looking at. So we are focusing in this Como County area that has Bulverde within it, and this black star that we have highlighted is the area that we will be looking at specifically for deer and mountain lion population data. Additionally, the surrounding area highlighted by this thick red line that is called Highway 46 has had a dramatic increase in construction, which has also in turn led to an increase in human activity, whether that be through development, travel, noise pollution, etc. And that may also have an effect on the mountain lion and deer behaviors and abundances, most notably for mountain lions, because they have a rather large geographic range, and so when that range is encroached upon, it leads to a smaller abundance of that population. So with this development and construction, we can also look at Bulverde as a metapopulation. And a metapopulation is a collection of these subpopulations that live in isolated patches and are connected by dispersal. So these metapopulations typically occur as a result of habitat fragmentation through human activities such as construction and development that we're seeing in Bulverde. So as we discussed a little bit with the geographic range of mountain lions, this habitat fragmentation will affect the distribution of the mountain lions as well as the deer, in addition to their interactions. And as a result of this, the interconnectivity of these patches is important for our predators to be successful, especially ones with the large geographic ranges, because if a mountain lion on one end of the metapopulation in a patch has a lower amount of prey available than another patch on the other side of the metapopulation, and those patches aren't very connected, it will cause a negative effect for our predators and they will be less successful in consuming and catching prey. So how we are collecting this data of our deer and mountain lion populations started in the fall of 2021, around November of 2021, and we will continue to observe these populations until the fall of 2022. So for the deer, at dawn and dusk, we go outside and walk the area highlighted on the map that I showed you in an earlier slide, and we count all the deer that we see. Alternatively, for the mountain lions, it's a bit harder to quantify their population because they like to stay away from human activity. So we do this through neighborhood apps and known sightings that are posted on these apps, and these apps include things like Nextdoor, that people will post, hey, saw a mountain lion, or they will post that there was a deer kill that is likely attributed to mountain lions. So we are equating one deer killing to one mountain lion in this count. Additionally, we can use this because deer are the main source of prey for mountain lions, so they are also considered a conventional predator as well as a top predator. The only error that we see with counting one deer kill as one mountain lion is that we're assuming that they're loner animals, but there has been evidence that shows that they are social animals and they have a sort of social hierarchy. And within this hierarchy, there has been evidence of prey sharing, so one deer could actually equate to 2 or even 3 mountain lions that are sharing their prey. Additionally, they are active at the same times of day as their prey, so in our scenario, they are mainly active and most sightings occur at dawn and at dusk. And mountain lions typically can exhibit some prey switching, which is when one prey species is rare. So if the abundance and occurrence of deer is rare, then they can switch to a different prey species that is more abundant. However, in Bulverde, deer are very abundant, so prey switching is highly unlikely in our model, and because of that, they also rarely cause harm to small pets and children because they typically have enough prey within the deer population to suffice. So additionally, they will avoid spots with human activity, as I mentioned before, and with the increase in construction and development in Bulverde, sightings of mountain lions were more common about 5 years ago before construction really began. And as a result of this, there have really only been 2 known mountain lion spottings in more secluded and quiet neighborhoods that are farther away from the highways and farther away from construction and development. On the other hand, our deer behavior is most common at dawn and dusk. At the same time, there's less human activity, so they also typically avoid busy highways and construction zones and are commonly seen on back roads or farm roads where there's not a ton of traffic. They're a little bit more accustomed to humans, just based on how evolution has occurred within Bulverde. So they don't seem to mind small pets and animals that may go outside and bark at them. They kind of just disregard it. But with that being said, they are still seen in groups, which contributes to this dilution effect that we talked about earlier, and they are also other grazing animals. So here's a quick snapshot of the data we have now of the deer sightings from November going into February. So the orange bars represent the sightings from morning and dawn, while the red bars represent sightings at night and dusk. We can see that they're mainly seen in groups of 2 or more. There were times where a sighting wasn't possible in these areas that have 0 number of deer, and that can be attributed to higher human activity in the area, or even like stormy, windy weather, especially on the 17th of February. That was a big restriction to the amount of deer that were in that area. So we can kind of tell from this data that we have that deer will avoid being eaten by staying in groups. And additionally, for people in areas with high mountain lion activity, they're advised to not hike or jog alone. So this also tells us that mountain lions will typically attack and capture prey when that prey is alone and not in a group, which also contributes to this idea of the dilution effect being very important for deer survival. Additionally, mountain lions very much dislike human activity, and deer don't like human activity, but they're a little more comfortable, especially in less busy backyards and around porches. So that may also be another strategy of deer to avoid mountain lions, is to stay a little bit closer to these backyards and porches that they know that mountain lions won't approach. So the model that will help us to show this oscillating relationship between the mountain lion and deer populations is the Lotka-Volterra model. So this is where dx dt represents the predators, while dy dt represents the prey. And A, B, C, and D are all positive constants. However, this model does not account for immigrations or emigrations or the concept of prey switching, but in our case, the concept of prey switching isn't likely, so we are able to neglect that idea in our model. Additionally, it does not consider the age structure of a population, so if there's a higher number of younger individuals that have not yet reached a reproductive age, they won't be considered as such in this model. So this model for the predators, dx dt, determines the rate at which the predator population grows based on the success of encounters with prey. So that is represented by the term bxy. That will be the growth in the predator population, while negative ax represents the death rate in this population. On the other hand, the prey equation, dy dt, represents the rate at which prey are eaten during these encounters with predators, and that is represented by negative cxy, while the dy set of variables represents the growth and the birth rate of the prey population. And we will be able to determine these constant values A, B, C, and D through the observations that we will continue to be making of our deer and mountain lion populations. So we will be able to use MATLAB, which is a coding language, to predict these interactions. So this will help us to create a model of the populations at equilibrium. And once we have developed a model, we are then able to manipulate the model to determine new equilibrium points in response to different scenarios. So for example, deer have been cited to be testing positive for COVID-19. So we can determine if that causes a significant decline in the growth of a deer population and what that does in terms of creating new equilibrium points for our model. So this is the relationship that we expect to see that represents this oscillating relationship between predator and prey populations over time, where T represents time in years, while population represents the number of predators and prey at a given time. So we can see that our predators is represented by this orange graph, while our prey is represented by the blue. And we can also see from this that we expect a time lag in our predator population in relation to the prey population. So this means that we expect that the predator population will respond to changes in the prey population. Additionally, we are able to create this phase plane plot, which is the period that we will expect to see through MATLAB. And this will give us the relationship between predator and prey populations in terms of their ratios. So this point is the joint equilibrium point, and this is the point that the model will oscillate around in which it is most stable. So since we are able to create different equilibrium points, we are then able to see changes in our predicted period and see how that affects when we move the joint equilibrium point. Thank you.